Good morning everyone. So students, today we are going to study the exercises of chapter 2. Okay, that is matter around us pure? The name of the chapter is matter around us pure? Okay, we will do the exercises of this chapter. But before moving towards the exercises, we will revise this chapter once. Okay, the explanation has already been done in the last class. I will just revise the chapter. What have you studied in the last class? Okay, after that we will move towards the exercises. Okay, so let's see what are the contents and let us revise once the chapter. So students, what did we study in this chapter? We studied whether the matter that is around us is pure or not. As we all know that the matter, the things that we see around us, it is all made up of matter. Yes or no? The things that we see, the solid, liquid, gas, all these matter are what? These are all matter. Yes or no? And they are made up of particles. And whether these matter are pure or not. Okay. Students, this matter are actually made up of mixtures. Okay, this matter is not pure, they are made up of mixtures. Many different kinds of mixtures. Okay, and what is a mixture? Mixtures are constituted by more than one kind of pure atom. Matter is constituted by more than one kind of pure atom. That means it contains more than one atom. Okay, it is a mixture of different components. The matter, the mixture is a mixture of different components. Okay, and what are the different types of mixtures? Those are homogeneous mixture and heterogeneous mixture. Okay, there are two kinds of mixtures, that is homogeneous and heterogeneous mixture. Now what is homogeneous mixture? Mixture that have a uniform composition throughout. Homogeneous mixture are those mixtures which have uniform composition. That means there is no different composition. It is made up of only one kind of mixture. That is homogeneous mixture. Okay. And homogeneous mixture have a variable composition. It has a variable composition. Okay. And what is a heterogeneous mixture? Mixture that contains physically distinct parts and have non-uniform composition. Heterogeneous mixture does not have only one kind of components. It has many different kinds of components. Okay. And they are non-uniform. That means they are not similar. They have different kind of composition. Okay. For example, what? Like mixture of sodium chloride and iron fillings. They are both different in composition than salt and sulfur. Yes. Then oil and water. These are what? These are heterogeneous mixture. Can you mix oil and water? No. We cannot mix. But what is homogeneous mixture? A solution of salt and sugar where both the sugar and solution are mixed together uniformly. Okay, those are homogeneous and heterogeneous mixture. There are two kinds of mixtures, that are homogeneous and heterogeneous mixture. Okay, and matter is made up of mixtures. Understood? Now students, what is a solution? What are solution? Solution is a homogeneous mixture of two or more substance. What is a solution? Solution is a homogeneous mixture of two or more substances. Okay. Solution are constituted with different parts, that is solvent and solute. A solution contains different parts, that is solvent and solute. Now what is solvent? The components of the solution that dissolve another component, that is solvent. That means which is present in larger amount, that is solvent. Okay, and what is solute? Solute, the components of the solution that is dissolved in the solution, that is solute. Okay, solution have two parts, that is solvent and solute. Solvent that is present in larger amount, in which the components is dissolved. Okay, into which the components gets completely dissolved. And what is a solute? Solute is a component that dissolve into the solvent. That is solute. For example, I can give like the solution of sugar and water. In the solution of sugar and water, water is solvent and sugar is a solute. Okay, because water is present in larger amount and sugar is present in lesser amount. Yes or no? So that is why sugar will be the solute and water will be the solvent, and together it makes up a solution. So solution have two parts, that is solute and solvent. Understood? Then next, what is there? What are the properties of a solution? See, okay, in the solution, I will give you some examples of solution. Okay, in the solution of sugar and water, water is the solvent and sugar is the solute. Okay, I already told you. Then in the solution of iodine in alcohol, that is also known as tincture of iodine. Iodine in alcohol is also called as tincture of iodine. Okay, it has iodine as solid and solute as alcohol as in liquid form. Yes or no? So here iodine is the solute and alcohol is the solvent. Okay. Then aerated drinks, like aerated drinks means that contains gas. For example, soda water, the cold drinks that you eat, what does it contain? It contains carbon dioxide. So what is the solute? Solute is the gas like carbon dioxide and all. And what is the solvent? That is the liquid. Okay, the water. Understood? Then air. Air is also a homogeneous mixture. Air is also a homogeneous mixture where air is the solvent and the gases are the solute. Understood? Air is a homogeneous mixture. In air there are different kinds of gases or not, like oxygen, nitrogen, carbon dioxide, methane, etc. These are the different kinds of gases that is present in the air. Yes or no? So it is also a mixture. Okay. Now, what are the properties of a solution? What are the different properties of solution? Solution is a homogeneous mixture. Okay. Then the particles of solution are smaller than 1 nanometer. The particles that is present in the solution are very small. Smaller than 1 nanometer. That is 10 to the power 9 meter. Okay, that is why the particles cannot be seen with the naked eye in the solution. Understood? Then, because the particles are very small in size, that is, they do not scatter a beam of light. That means the light cannot pass through the solution because the particles are very small. And if the particles are very small, how will they absorb the light? And if they are not absorbing the light, then how can the light pass from that solution? Yes or no? So that is why the light cannot pass. The beam of light cannot pass through the solution. Okay. The solute particles cannot be separated from the mixture by the process of filtration. If you filter the solution, the particles cannot be separated because the particles are so minute that they are uniformly distributed throughout the solution. Okay. Then in a solution, the relative proportion of the solute and solvent can be varied. It can vary. The solute and solvent can vary in a solution. Okay. Depending upon the amount of solute present in the solution. It can be vary means it can be distinguished. Depending upon the amount of solute or solvent present in a solution. Okay. It can be called as a dilute solution, or it can be called as a concentrated solution, or it can be called as a saturated solution. The solutions can be distinguished depending upon the amount of solute or solvent present in the solution. Okay, a solution can be distinguished like whether it is a dilute solution, or it is a concentrated solution, or it is a saturated solution, depending upon the amount of solute or solvent present in the solution. Okay, then what do you mean by saturated solution? What is saturated solution? Saturated solution means when no more solute can dissolve in that solution. Solute means the lesser part, okay, the one which you dissolve in the solvent. Okay, when that solute cannot be dissolved in a solution at a given temperature, then it is a saturated solution. Understood? The amount of solute present in the saturated solution given at the given temperature, it is called its solubility. The amount of solute present in the saturated solution at the given temperature is called its solubility. What is saturated solution? Saturated solution means when no more solute can be dissolved in the given solvent. Okay, in the given solution, when the solute cannot be dissolved at the given temperature, then it is a saturated solution. Understood? Then, if the amount of solute contained in a solution is less than the saturation level, it is called as unsaturated solution. What is unsaturated? Unsaturated means if the amount of solute contained in a solution is less than the solution. The solute is less than the solution, then it is unsaturated solution. Okay? Then what is concentration of a solution? Concentration of the solution is the amount of solute present in the given amount of solution. The amount of solute present in a given amount of solution, that is concentrated solution. Okay. Then what is suspension? You know what is suspension? Suspension means it is a heterogeneous mixture. Okay. Suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the medium. Okay, throughout the bulk of the medium. In suspension, the particles are not completely dissolved. Some particles get settled down in the solution. That means they are not completely dissolved. Okay. And in suspension, the particles of the light can pass through because the particles are not completely dissolved in the solution. That is why the light can pass through a suspension. Okay. Now what are the properties of a suspension? Suspension, it is a heterogeneous mixture. Okay. The particles of suspension can be seen with the naked eye because the particles are not very minute. Okay. Then these particles of suspension can scatter a beam of light. That means the light particles can pass through a suspension. Okay. The solute particles settles down. That means the solute particles don't get dissolved completely into the solution. It gets settled down. Okay. So these are the few properties of a suspension. Okay. Then now comes the colloidal solution. What is a colloidal solution? What do you mean by colloidal solution? So students, in solution like milk and ink, okay, in the solution like milk and ink, the particles of colloid are uniformly spread throughout the solution. Yes or no? If you mix ink with water, the ink get mixed with the water or not? That means it is uniformly mixed with the water. Okay, that ink is the colloid. Okay, are uniformly spread throughout the solution. And due to the relatively smaller size of the particles of the ink are very smaller in size as compared to that of suspension. The particles in the suspension are not very minute. They get settled down. Yes or no? But in colloid, the particles are little bit minute than that of suspension. Okay. The mixture appears to be homogeneous since they get completely dissolved, uniformly dissolved into the solution. That is why they seem as homogeneous mixture, but actually they are heterogeneous mixture. This colloidal solution are actually the heterogeneous mixture. Okay. Then the particles of colloid are very small. That is why it cannot be seen with the naked eye. But it can scatter the beam of light. But the light can pass through because the particles are not completely dissolved. Okay. Though the particles are very minute in colloidal solution, the light can easily scatter. Okay, the light particles can pass through the colloidal solution. For example, I can say the mixture of milk and water. Okay, and the mixture of ink solution. Understood? Then, students, what are the properties of a colloid? Properties of a colloid is, it is a heterogeneous mixture. It is a heterogeneous mixture, okay? Colloids are big enough to scatter a beam of light. Scatter a beam of light means the light can easily pass through a colloidal solution. Okay? Then they do not settle down when left undisturbed. The particles of the colloidal solution do not settle down when they are left undisturbed. Okay? Then they cannot be separated by the process of filtration because the particles are not settling down. That is why they cannot be separated by the process of filtration. The particles cannot be separated by the process of filtration. Okay. So students, do you know what is Tyndall effect? What do you mean by Tyndall effect? Tyndall, Tyndall effect. Tyndall effect means the scattering of light by the particles of dust and smoke in the air. What is Tyndall effect? The scattering of light. The light gets scattered. Okay. It gets scattered by the particles of dust and smoke present in the air. That is called as Tyndall effect. Understood? Now students, what do you mean by centrifugation? What is centrifugation? C-E-N-T-R-I-F-U-G-A-T-I-O-N. Centrifugation. Centrifugation is the process. The principle is that the denser particles are forced to the bottom and the lighter particles stays at the top when spun rapidly. Centrifugation is a process, okay? It is a spinning process where the denser particles of the matter are settled down and the lighter particles comes to the bottom of the solution. When we use the process of centrifugation, the denser particles get settled down and the lighter particles, they comes on the bottom, on the top of the solution. Okay, when they are spun rapidly, spun means when they are rotated very forcefully. Okay, in a very speed way. When they are rotated, the denser means the thick particles are settled down and the lighter particles, they comes up. That is centrifugation. That is the process of centrifugation. Okay. And where is this centrifugation method used? You know, it is used in the diagnostic labs for blood and urine test. Okay. And it is also used in dairies and at home to separate butter from cream. Okay, if you want to take out the butter or cream from milk, you use the process of centrifugation, where the milk is spun very rapidly, it is rotated very rapidly. The denser particle of the milk, they settle down, and the butter, the cream that is lighter in weight, they comes up. They come on the top with the process of this centrifugation. Okay. It is also used in washing machine to squeeze out the water from the clothes. Okay. Then this centrifugation method is also used to separate oil from water. Okay. Then students, what do you know the process of chromatography? What is chromatography? Chromatography is the process of separating components of a mixture. Okay, chromatography is a process of separating the components of the mixture. Basically, this chromatography is used to separate the colors, the color component of a mixture. Okay, it is used to, this technique was first used to separate color pigments from the components. This chromatography technique was first used to separate color pigments from the components. This chroma word from the chromatography, chromatography, chromatography. This chrome means color. Okay, it is the process where you can separate the color pigment from the component. Okay, this is the process of chromatography, where you can separate the color pigment from the components. Okay. Then where do we use this chromatography process? We use to separate the color from the dye. Okay. Then pigments from the natural colors. Okay. Then drug from blood. This chromatography is used to separate the color in dye, then pigments from the natural colors, then drug from the blood. Okay. Then what do you mean by crystallization? What is the process of crystallization? What is crystallization? Crystallization is the process to separate pure solid in the form of its crystal. Crystallization is the process to separate pure solid in the form of its crystal. For example, salt that is extracted from the seawater. Okay, it is purified by the process of crystallization method. Understood? Then, what are the physical and chemical properties of a matter? What do you mean by physical properties? Physical properties are those that can be observed like color, hardness, rigidity, fluidity, density, melting point, boiling point of a matter or a substance. Those are the physical properties of a matter. Okay, that can be observed, that can be seen. Like we can see the color, the hardness, the rigidity, the fluidity, the density, the melting point, the boiling point of a matter, yes or no? So that is the physical property of a matter. Okay. The properties into which a substance reacts with another substance. Now what is chemical property? The properties into which a substance reacts with another substance to form a new substance. That is chemical property. Physical property is that there is no change in the component of the matter. Okay, there is no change. That means it is as it is. Okay. Now what are the chemical properties? In chemical property of a matter, there are some changes. Okay, there are some changes. That means a substance, when it is reacted with another substance, it forms a new substance. In chemical change, in chemical reaction, when a substance is reacted with another substance, it forms a new substance. So these are the chemical and physical properties of a substance. Okay. Now students, on the basis of chemical composition of a substance, the substances are classified into elements and components. Okay? On the basis of chemical composition of substance, the substances are classified into two types, that is elements and components. Okay, so what are the elements? Elements are the basic form of matter that cannot be broken down into simpler form. Okay? Elements are the basic form of matter that cannot be broken down into the simpler form. For example, metals, non-metals, metalloids. What are metalloids? Metalloids are those substances that have the characteristics of both metal as well as non-metal. Okay. Then what are compounds? Compounds are substances that are composed of two or more elements chemically combined with one another. That are compounds. Okay. So these are the few topics that you have studied in this chapter. So now let us move towards the exercises, the question and answers of this chapter. Okay, I hope you understand. So now let us move towards the question and answers. So students, let us begin with the question and answer, okay? Our first question is, what is meant by a substance? I repeat, what is meant by a substance? What do you mean by a substance mean? The answer is, a pure substance is the one that consists of a single type of particles. That is, all constituent particles of the substance have the same chemical nature. Pure substance can be classified as elements or compounds. What is a substance? A pure substance is the one that contains a single type of particles. That means it has only one type of particles. All the constituent particles of the substance have the same chemical nature. Okay, they have the same chemical nature. Pure substance can be classified as elements or compounds. Okay. Question number 2. List the points of difference between homogeneous and heterogeneous mixture. What are the difference between homogeneous and heterogeneous mixture? The answer is, difference between homogeneous and heterogeneous mixture are. So students, the answer is, a homogeneous mixture is a mixture having a uniform composition throughout the mixture, full stop. For example, salt in water, sugar in water, copper sulfate in water. A heterogeneous mixture is a mixture having a non-uniform composition throughout the mixture. For example, sodium chloride and iron fillings, salt and sulfur, oil and water. I repeat the answer again. A homogeneous mixture is a mixture having a uniform composition throughout the mixture. For example, salt in water, sugar in water, copper sulfate in water. A heterogeneous mixture is a mixture having a non-uniform composition throughout the mixture. For example, sodium chloride and iron fillings, salt and sulfur, oil and water. Okay. Question number 3. Differentiate between homogeneous and heterogeneous mixture with examples. You have to differentiate. That means you have to give the difference between the homogeneous and heterogeneous mixture with examples. Okay. Students, the answer is, a homogeneous mixture is a mixture having a uniform composition throughout the mixture. For example, mixture of salt in water, sugar in water, copper sulfate in water, iodine in alcohol, alloy and air have uniform composition throughout the mixture. Now heterogeneous mixture. On the other hand, a heterogeneous mixture is a mixture having a non-uniform composition throughout the mixture, full stop. For example, composition of mixture of sodium chloride and iron fillings, salt and sulfur, oil and water, chalk powder in water, wheat flour in water, milk and water are non-uniform throughout the mixture. Okay? I repeat the answer again. A homogeneous mixture is a mixture having a uniform composition throughout the mixture. For example, mixture of salt and sugar. Mixture of salt in water, sugar in water, copper sulfate in water, iodine in alcohol, alloy and air have uniform composition throughout the mixture. On the other hand, a heterogeneous mixture is a mixture having a non-uniform composition throughout the mixture. For example, composition of mixture of sodium chloride and iron filling, salt and sulfur, oil and water, chalk powder in water, water in flour, wheat flour in water, milk and water are not uniform throughout the mixture. Okay? So students, now question number 4. How are salt solution and suspension different from each other? I repeat, how are salt solution and suspension different from each other? The answer is, salt is a heterogeneous mixture. In this mixture, the solute particles are so small that they cannot be seen with the naked eye. Also, they seem to be spread uniformly throughout the mixture. The Tyndall effect is observed in this mixture. Full stop. For example, milk of magnesia, mud. Okay. Solution is a homogeneous mixture. Full stop. In this mixture, the solute particles dissolve and spread uniformly throughout the mixture. The Tyndall effect is not observed in this mixture. For example, salt solution, sugar in water, iodine in alcohol, alloy. I repeat again, salt is a heterogeneous mixture. In this mixture, the solute particles are so small that they cannot be seen with the naked eye. Also, they seem to be spread uniformly throughout the mixture. The Tyndall effect is observed in this mixture. For example, milk of magnesia, mud. Number 2, solution is a homogeneous mixture. In this mixture, the solute particles dissolve and spread uniformly throughout the mixture. The Tyndall effect is not observed in this mixture. For example, salt in water, sugar in water, iodine in alcohol, alloy. Okay, these are the examples. Number 3, suspension. Suspension are heterogeneous mixture. In this mixture, the solute particles are visible to the naked eye and remain suspended throughout the bulk of the medium. The Tyndall effect is observed in this mixture. For example, chalk powder and water, wheat flour and water. I repeat, what is suspension? Suspension are heterogeneous mixture. In this mixture, the solute particles are visible to the naked eye. We can see the particles of the mixture. Okay? And the mixture remains suspended throughout the bulk of medium. The Tyndall effect is observed in this mixture. Tyndall effect means the particles of the light can be scattered, can pass through this solution. Okay? For example, chalk powder and water, wheat flour and water. Okay? Question number 5. To make a saturated solution, 36 gram of sodium chloride is dissolved in 100 gram of water at 293 Kelvin. Find its concentration at this temperature. What is written? To make a saturated solution. What is saturated solution? Where the solute is dissolved at the given temperature. Yes or no? Where no more solute can be dissolved in the given temperature. That is saturated solution. Okay. you have to make a saturated solution where 36 gram of sodium is dissolved in 100 gram of water at what temperature? At 293 Kelvin. 293 Kelvin is the given temperature. Okay, and you have to dissolve 36 gram of sodium chloride in 100 gram of water, and you have to find its concentration at its temperature. And what do we need to find? We need to find the concentration of the solution at the given temperature, that is 293 Kelvin. Okay? The answer is, the solution of the question is mass of solute, that means sodium chloride. It is 36 gram, that is given. Yes or no? How much gram of sodium chloride is given? It is 36 gram. So you have to write mass of solute. Solute means sodium chloride is to be dissolved in the water. That is why it is a solute. That is mass of solute. Sodium chloride. Sodium chloride is the solute. That is 36 gram. That is given. And mass of solvent. Mass of solvent means water. Water is the solvent in this solution. What is the mass of solvent? That is 100 gram. Given. Yes or no? Now, mass of solution is, what is the formula? You have to find the mass of solution. Yes or no? If you mix the solute and solvent together, what will be the mass of the solution? That means the mass of solution is equal to mass of solute plus mass of solvent. That means 36 plus 100 gram, which is equal to 136 gram. That means the mass of solution is 136 gram. Okay. Now you have to find the concentration of this solution. You have to find the concentration of this solution. Therefore, concentration, that means mass by mass percent. You have to find the concentration by mass percentage of the solution. Okay. So the formula is mass of the solute divided by mass of the solvent into 100. To find the concentration of the solution, you have to divide mass of the solute by mass of the solvent into 100. Into 100%. So it will be 36 divided by 136 into 100%. Okay. 36 divided by 136 into 100%. The answer is 26.47%. So the concentration of the solution at the given temperature, that is 293 Kelvin, it is 26.47%. Okay, the concentration of the solution is 26.47%. Okay. So now students, question number 6. Okay. How will you separate a mixture containing kerosene and petrol? Difference in their boiling point is more than 25 degrees Celsius, which are miscible with each other. Miscible means which are dissolved with each other. Okay, which are uniformly dissolved with each other. Okay, how will you separate this mixture of kerosene and petrol? And the difference of their boiling point is more than 25 degrees Celsius. Okay, there is a difference between their boiling points. The kerosene have different boiling point and the petrol have different boiling point. And the difference between their boiling point is more than 25 degrees Celsius. Okay, the answer is a mixture of two miscible liquids having a difference in their boiling point more than 25 degrees Celsius can be separated by the method of distillation. How can it be separated? It can be separated by the method of distillation. Distillation is the process to separate two miscible liquids. Okay. Thus, kerosene and petrol can be separated by distillation. Can you see the picture? That is the distillation process done. Okay. The That is how the distillation process is done. Okay. So students, what is done in this method? In the method of distillation, first the mixture of kerosene and petrol is taken into the distillation flask with a thermometer fitted in it. Okay, the mixture of petrol and kerosene is taken into the distillation flask with a thermometer fitted in it. The thermometer is used to check the temperature. Okay, then a beaker, a water condenser and a Bunsen burner is needed. What is needed? A beaker, a water condenser and a Bunsen burner is needed. Okay. The apparatus is arranged as shown in the figure. The figure that you have seen, it is arranged in that manner. Okay. Then the mixture is heated slowly. The mixture is heated slowly. The Bunsen burner is used to heat the mixture. Okay. After that, the thermometer should be watched simultaneously. You have to record the temperature. Understood? Then, kerosene will vaporize and condense in the water condenser. When the mixture is heated, the kerosene will vaporize and it will condense. It will flow through the condenser and it will condense in the water condenser. Okay. The condensed kerosene is collected from the condenser outlet, whereas the petrol is left behind in the distillation flask. Okay, the kerosene will vaporize as it is lower in density. That is why it will vaporize and it will flow through the condenser. Okay, and it will be collected in the condenser, and the condensed kerosene will be collected in the condenser, in the water condenser, and the petrol will be left behind into the distillation flask. Okay, the petrol will be left behind into the distillation flask. This is how you can separate the mixture of kerosene and petrol. Understood? So students, this is all for today. In the next class, I will give you more question and answers. Okay, we will continue with the question and answers in the next class.